Hi students, these notes will teach us how to write the equations of lines that are either parallel or perpendicular to other lines. So before we learn how to do that, we first need to make sure that we understand what parallel lines and perpendicular lines are. So parallel lines, you probably are more familiar with. These are lines that will never intersect or touch. So down at the bottom, I have an example of some parallel lines. And notice that, remember with lines, they go on and on forever in either direction. They will never intersect. These lines will never intersect, okay? What you might see sometimes on a picture for parallel lines is you'll see little arrows within the lines, not at the ends, okay? The symbol for parallel lines are two long vertical lines next to each other. That's actually the symbol. Notice also in the word parallel we have the symbol for parallel lines. We have some parallel lines in the word parallel lines. All right, now let's talk about perpendicular lines. These are lines that sometimes students get mixed up with just intersecting lines. Perpendicular lines are a special type of intersecting lines. So intersecting lines are just lines that cross, right? We've talked about that, y-intercept crossing the, a line crossing the y-axis at the y-intercept, intersecting. These lines that I just drew are just intersecting lines. This is not what we're talking about. Perpendicular lines are lines that intersect or cross at a right or 90-degree angle. So down at the bottom, the angle that they make with each other is 90 degrees or a right angle. Okay? So it's a special type and they have to make a 90-degree angle or they're just intersecting lines. The symbol for perpendicular is an upside down capital T, so I want you to be familiar with that. You will also use that symbol in geometry when you take geometry. Okay? So we're going to go ahead and start off by reviewing slope and how to find it on a graph with a couple different lines. So you've got 4 lines on this graph. We're going to find the slope of each one. Let's start with line A. So remember, when you find slope on a graph, you just need to locate any 2 points on that graph. So maybe I'm going to choose these 2 points, and then you're going to make the triangle between them either above or below the line. And then you're going to count the rise. In this case, it's 1. That's the vertical change. And you're going to count the run. In this case is 2. That's the horizontal change. Remember, you're counting the spaces. Overall, this line has a positive slope because it moves up from left to right. So the slope is going to be the vertical change of 1 over the horizontal change of 2. So there's the slope of line A. Now let's do the same with line B. I'm going to again pick 2 points from line B. Maybe this point and this point. Sorry, it's hard for me to make points. And then we're going to draw our triangle, again, either below or above the line. The vertical change is also 1. The horizontal change is also 2. It also moves up from left to right, so it's positive. So just like line A, it has a slope of 1 over 2. If you notice, these 2 lines also appear to be parallel. They do not intersect, and if they were to continue in both directions, I could assume that they also would not intersect. So let's stop real quick and take a look at parallel lines. Parallel lines, what we can conclude is that they have the same slope. These slopes are the slopes of parallel lines. And the reason is, remember, the slope tells you the steepness of a line or kind of how it's angled. Well, if they're angled in the same direction at the same angle and they go forever and ever, they're never going to intersect. So lines that are parallel have the same slope. I need you to remember that. All right, let's keep going. Let's look at the slope of line C. So line C, let's choose maybe this point and this point. All right, let's make our triangle. The vertical change is 2 spaces. The horizontal change is 1 space. It also looks positive, going up from left to right. So it's going to have a slope of 2 over 1. All right? And then line D, let's pick two other points from that line. Maybe these 2 points. Let's make our triangle. Our vertical change is 2. Oops. Our horizontal change is 1. This time our line is moving down from left to right, so it's going to have a negative slope. And the vertical, or 2, goes on top. Horizontal change of 1 goes on bottom. So now let's compare lines that are perpendicular. This right angle here, this box, means we have a right angle. That indicates that those two lines, lines D and A, are perpendicular because they intersect at a right angle. Okay, so let's take a look at the slopes of lines D and A. Here's the slope of D. A is up here. If these are to be perpendicular, which they are, let's look at their slopes. Notice one slope is positive, one is negative. Notice also that the numerators and denominators have been switched or flipped. Those are called, that means reciprocal. They're reciprocals of each other. So whenever you have perpendicular lines, their slopes are going to be opposite. Remember, opposite, that means one is positive, one's negative. And they're also going to be reciprocals. That means flips of each other. And these are their slopes. Okay, so I also need you to know this. So just to recap, for parallel lines have the same slope, exactly the same. Perpendicular lines have both opposite and reciprocal or flipped slopes. They have to have both. Now notice line C we didn't talk about. Look at the slopes of line C with lines D and A. Notice it's not parallel to lines A or B or D, and it's not perpendicular to lines A, B, or D. It's got some of the same numbers in the slope, right? But so for example, with B and C, those are reciprocals, but they're not also opposites. With lines C and D, their slopes are exactly the same, not reciprocals, but they are opposites. So notice that line C slope doesn't have both opposite and reciprocal slopes with any of the other slopes, and it doesn't have the same slope as any of the other slopes. So when it intersects lines A, B, and D, it's just intersecting lines. They're not perpendicular. Okay, so now we're going to take some given slopes in the left column, and we're going to either change or keep the slopes to represent the slopes of a line that would be parallel or perpendicular to the line that contains the given slope. Remember, for parallel slopes, those are the same, so you're just going to rewrite those slopes. Perpendicular slopes have to be both opposite, that means they have different signs, and reciprocal, that means they're flips of each other. So these have to have both, not one or the other, but both. So for the given slopes, if my given slope is 2/3 and I want to write a line that's parallel to it, I'm going to use the exact same slope of 2/3. Okay, but if I want to make a line that's perpendicular to it, I'm going to do the opposite, so it's now going to be negative, and I'm going to flip it. So I'm going to have the 3 on the top and the 2 on the bottom. You've got to have both. All right, let's look at a given slope of -4. So for a parallel slope, it would be the same. For perpendicular slope, I would want to change its sign, so now it's going to be positive, and I want to flip it. Now since it's not already a fraction, remember I can always put it over 1 to make it a fraction. Now I have some numbers to flip, so I'm going to have a 1 on the top and a 4 on the bottom. So that's the perpendicular slope. I changed the sign and I flipped it. All right, given slope of -1/4, the parallel slope is going to be the same. And we can just repeat these slopes all the way down for the parallel slopes. Those are easy. Perpendicular slope, remember we have to change the sign and flip it. So the perpendicular slope of the given slope of -1/4 would be positive 4/1. Or you can just write it as 4. Either one is fine. But you need to be able to recognize it both ways. All right, the perpendicular slope of 2, I need to change the sign so it needs to become negative. And I need to flip it. So if I put 2 over 1, now I can flip it. So there's going to be 1 on top and 2 on bottom. Perpendicular slope of a 0 slope. So I want you to remember what a 0 slope looks like. It's going to be flat. The perpendicular to a horizontal line is going to be a vertical line. And remember, the slopes of that kind of line is undefined or no slope. If you forget, you can always do the opposite reciprocal. Opposite of a positive 0 is a negative 0. It doesn't really make sense because 0 is not positive or negative, so it just stays 0. And then if you put 0 over 1 and flipped it, you will get 1 over 0, and anything divided by 0 is just going to be no slope. So if you put that in the calculator, it'll just say error or something like that. Okay? So keep in mind those special cases. All right, let's try some examples. So in these examples, you're given 2 equations, and you are going to identify the slopes, and then based off what they look like, determine if the 2 lines are parallel, perpendicular, or neither. Neither just means they would be intersecting. And it appears that all of these lines are in slope-intercept form. Y equals mx plus b. So remember, we are focusing on just the m, the slope, right? All right, so for number 1, our 2 slopes are negative 1/2 and positive 2. If I put that positive 2 over 1, I can see that if I flipped that, I'd get 1 over 2, which is the slope on the left, and I have a positive and a negative slope, which means these 2 slopes are opposite reciprocals of each other, which means these 2 lines are perpendicular. So you can either write the word perpendicular, it's a pretty long word, or you can just put the perpendicular symbol. I'm cool with that as well. All right, next 2 lines, the slopes are positive 3 and negative 3. Now, while they are opposites of each other, they're not also reciprocals. So the reciprocal of 3 would be 1 over 3. Since they are only opposites, that does not mean they're perpendicular. They're not the same, so they're not parallel. So we're just going to say that they're neither. And that just means they're just intersecting lines, right? They just cross, but not at a right angle. But they will cross. All right, the last 2 lines. The slope on the left line is a little harder to see. I've got x over 7. Now remember, in front of x, there's a 1. So if I kind of pull that out, this is like 1 over 7, right? And then the slope on the right is 1 over 7. So since they are the same, that means these 2 lines are parallel. They will never intersect because they have the same slope. You could also just put the symbol for parallel. That's fine as well. So sometimes you'll have to identify from an equation. Now, if the equation is given to you in standard form, we've done some things. We know how to convert that to slope-intercept form so that we can then see the slope. So you'll have to do those 2 steps if the equations are given to you in standard form. Okay, now we're going to actually write some equations. So these are how the problems are going to be given to you. They'll say write the equation in slope-intercept form, which remember is y equals mx plus b. So we want it to look like that, of a line that passes through this given point of 2, 9. So I'm given an x and a y, and is parallel to this equation. So this is what I was just talking about. In this form, this equation is in standard form. And remember, in standard form, I can't see the slope. But if I'm going to make the equation of a line that is parallel to this line, I've got to see the slope, right? So what we're going to first do is we're going to first change this equation into slope-intercept form. We need to make it look like this so that I can see that slope, which is what we just talked about a minute ago. So remember the steps for that. Let me rewrite it first off to the side. Oops. 5x minus 2y equals 8. All right, so there's 2 steps to convert that into slope-intercept form. The first step is to move your x term to the other side, and we're going to do that by subtracting. the x term, minus 5x on both sides. We're left with negative 2y on the left. On the right, the constant and the x term are not like, so we can't put them together. So we'll put the x term first, followed by the constant. The second step is to divide every term by the coefficient of y, which is negative 2. Every single term gets divided by negative 2. On the left, negative 2 divided by negative 2 is 1. 1 times y is y. So I've got y equals. On the right, I'm going to simplify or reduce these fractions. Negative 5 over negative 2, when you have a negative in the top and bottom, that simplifies to a positive. So positive 5/2 x. And then 8 over negative 2 simplifies to negative 4. But the whole purpose of doing this was to find the slope of that line, which I can now see is 5/2. That's the slope of this line. Now I'm going to be rewriting the equation of another line that's parallel or has the same slope of 5/2. I also want it to travel through this point of 2, 9. Now if I just wanted a normal parallel line, I could come up with any equation that had this 5/2 as the slope, but I also want it to go through that particular point. So whenever you have the slope and the point of a line that you want to write the equation for, you use point-slope form, which remember is y minus y1, this is what we did earlier, equals m times x minus x1. And just to remind you guys, we're going to be replacing the m with the slope we want and the x1 and the y1 with the point that we want. So let's go ahead and do this. So y minus the y1 of our point is 9 equals the slope that we want is this 5/2 because we want it to be parallel to this line over here. Parentheses x minus the x1 of the point is 2. So just to show you what we did, we replaced the slope and the x and y of the point we want it to go through. So remember what we do now. So right now this is in point-slope form, but remember we want it to be in slope-intercept form. So now we're going to distribute that slope into our parentheses, multiply it by the x and the negative 2. So we have y minus 9, let me draw my line, equals 5/2 times x is just 5/2 x, minus 2. So we're going to multiply 5/2 times 2. Remember, you can put the 2 over 1. Multiply your numerators together. I'll do this off to the side. First of all, positive times a negative is a negative. 5 times 2, we're going to multiply our numerators. We get 10 for the numerator. Our denominators are 2 times 1, so that's 2. And negative 10 over 2 simplifies to negative 5. So I just kind of simplified it off to the side there. Okay. Now we're going to move that minus 9 to the other side by adding it to both sides. And we'll combine it with the constant on the right side, which is the negative 5. So we've got 5/2 x, and then the negative 5 and the positive 9 combine to make a positive 4. So this is the equation in slope-intercept form of the line that is parallel to this given line, meaning it has the same slope of 5/2, and I can still see that in my equation, but it also goes through this point 2, 9. Okay, so we had to start with that point-slope form and then rearrange it into this slope-intercept form. Let's try another one. This time we're doing the same thing. We're writing an equation in slope-intercept form, so we want it to look like y equals mx plus b. But this time, not only do we want it to travel through a particular point, this time 6, negative 13, but this time it needs to be perpendicular to this line that's given to us, okay? Now the good thing is this line is in slope-intercept form, so I can see the slope right now. Right now it has a slope of 2/9. But if I want to make a line that's perpendicular to that, we have to change the slope to its opposite reciprocal. So since it's positive, we're going to make it negative. That's the opposite. And the reciprocal of 2 over 9 is 9 over 2. So this is really the slope that I want to use in my equation. It's really easy to accidentally use the original slope when you're making a perpendicular equation, but make sure that you switch it around, opposite and reciprocal, and use that slope. So this is the slope we're going to use, and then this is the x and y that we're going to use. So because we have slope and a point, we're going to start with our point slope form, which is y minus y1 equals m times x minus x1. Remember, we're going to replace the slope and the x1 and y1 with our point. So let's go ahead and do that. So we've got y minus, the y value of our point is negative 13, equals, the slope that we want is this negative 9/2. That's the perpendicular slope, the opposite reciprocal. Parentheses, x minus, the x of our point is 6. Okay, so we replaced the slope, the x and y of our point. Now we're going to kind of simplify and rearrange it so that it looks like slope-intercept form. So let's do that. So first thing we're going to do is we're going to distribute that slope inside of our parentheses. Also on the left, I've got minus and negative, which is the same as adding a positive. So I could rewrite the left side as y plus 13. All right, let's distribute that negative 9/2. Negative 9/2 times x is negative 9/2 x. Negative 9/2 times negative 6. First of all, a negative times a negative is a positive. Let's put that 6 over 1. I'm going to multiply it off to the side and then simplify and put it back into my equation. So if we multiply our numerators, 9 times 6 is 54. If we multiply our denominators, 2 times 1 is 2. And 54 divided by 2, or over 2, simplifies to 27. So this 27 came from the 54/2. All right, so we distributed. Now we're going to move that plus 13 to the other side by subtracting it from both sides. So y equals negative 9/2 x, and then 27 minus 13 is positive 14. So here is the equation in slope-intercept form of the line that is perpendicular to this line and travels through this point. Notice in slope-intercept form you can see the opposite reciprocal of the slope that's given to you, right? Now this y-intercept we got because we started with point slope form. So in point slope form we couldn't see the y-intercept, but it kind of gave it to us. But we had to start with point slope form because we also wanted it to travel through this point. Okay, write down your questions, bring them to class. I'll see you soon.